Hey everyone, you're watching the Inside Out BIM, and today we're continuing our series on vectors. In this case, having a look at dot product. If you haven't watched the first part, make sure to do it because we covered the essentials of vectors in that video. Before getting started, if you find the content useful, please like this video, subscribe to the channel, and turn on notifications. So let's kind of just have a look at what inputs do we need to have to make our dot product work and what it will give us. So go to geometry, abstract, vector, and here we have a node that is responsible for the dot product. So here, as you can see, you have two inputs and you need to pass two vectors. But when we used cross product, we actually passed like two vectors, and as a result, we've got like another vector, and we actually know how to visualize our vectors. But now we are kind of having just some number, just some value. So basically, we cannot visualize it. So let's kind of understand what a dot product is, what that value actually represents. So if I kind of move it here, I've kind of found I Googled and just a simple app for visualizing the dot product. So as you can see, I have here two vectors, and as I move this one, I have this is actually what a dot product is. So we have one vector, we have the other one, and we're kind of projecting like 90-degree relationship to this vector. So we've got this vector, we've got this one. We kind of draw a perpendicular, right? So here we're going to maintain 90-degree relationship, and that will be the length of it. So just we've got the idea. We're going to go back to this, right? I just want to kind of show you how that is going to be in Dynamo. So again, these reference planes in my case represent just the origin in Revit in our global coordinate system. Let's just model two lines and kind of have, I'm going to model them like this, and I'm going to grab them to Dynamo, right? Select model element. I'm just going to do them separately, or we can let's gonna go with select model elements, and then I'm just gonna by index select them. Oops, I think there is some line here that I need to delete. Yeah, so now I have, let's kind of reselect them. So let's get the geometry out of these lines. I'm doing this from Revit elements because it's kind of easy to rotate them and kind of see what is going on there. So first of all, they're huge, right? These lines are kind of huge. I want to flatten this for the time being. So I'm gonna flatten this because I don't want to have this structure. So we're just preparing our work so we can actually easily visualize it. And now I'm gonna have my first vector here, not even vector, but lines. So I'm gonna work like that. So I'm just telling that A is this list, right? So that is my A. And from A, I can kind of specify how I can get these elements. So I go A and specify in these brackets like the index 0 or 1, and this will get me this line. So for example, if I do this that way, it can give me the lines. So we've got two separate lines, and actually even though we've got two of them, here it's going to display the last one, but we don't care about this that much. We're gonna just hide the geometry. And as you can see, even though here we have one, but when I select, it selects two. What we know that we can create a vector by line by just getting the start point and end point and create vector by 2 points. But actually our line has its cool property. So if I go to curves, line, it has a direction. And I'm gonna get the directions of both of these lines like that. And as we already know, we can visualize our vectors. So to make it easier, so I'm going to turn on the preview, high geometry preview, and I'm going to go with the line. Actually, I have it here, by start point, direction, and length. So I'm going to pass a vector here as the direction. Start point is going to be origin, and length will be the length of this vector. So I'm going to go vector, vector dot length, like this. And of course, I don't want to have this huge vector. I just want to have normalized. I don't care about the length right now. I just care about the direction of this. So I can go to abstract, vector, and use normalized to just normalize the vector. Actually, if you want to really kind of do this faster, we can do this and type this in a code block, but that can be quite intimidating for people who are not familiar with programming, like in it in like texting programming, right? When we go, for example, line by start point, direction, and length, we can do this that way, and that will be faster. I can go point, origin. Now I'm gonna explain why I'm doing this that way, if that is like of an interest to someone. And here I'm gonna pick the vector and length. So if I do this that way, now what I need to do is to simply connect the vector, and that's it. Uh, Point. So I think start point direction. Oh, direction. Yeah. Here that should be vector, and then that should be length. Length, like this. So it can be done easier. So that is just the replacement for this. I That is for someone who is interested in it, but I don't think that a lot of people would kind of actually want to do this that way in Dynamo, because if you can do this that way, maybe it's time for you to shift to texting programming. Okay, so here I'm gonna visualize this normalized vector. So I'm gonna pick up the length from here and direction like that. And let's select it and move closer to this. So that is our first vector, and that will be our second one. Actually, there is no point in visualizing that much, because if I go there and connect this one, this will be that vector. So these are the two vectors that we have. So we will kind of visualize them here from Revit, okay? So we are not using this part anymore, because that is not easy to kind of that is going to be really messy to have all of these nodes together. So now we have two of these vectors, and let's just get the dot product of two of them. So here I have this one that is represented like this. Actually, okay, it's not that much of nodes, so it's kind of easy to do this that way, so we can actually see the way that they changes. And here we have two of these normalized vectors. Keep in mind that it's vitally important that they're normalized right now. So let's see what kind of value do we get. 0, zero point 0.3, right? So we have like one. Let's kind of see what we actually, how that is changing when we're kind of moving it. So let's kind of move it there, like here. It's just changing the value. The sign is pretty much the same. For example, let's make a 90-degree vector. So here and here we'll have like 90-degree, right? So if I were to kind of create a dimension like this angular, we'll have 90-degree. As you can see, when we use dot and there is a 90-degree connection relationship, so even if I move it here and it's 90-degree as well, as you can see, it's 0. So we can get like the cool way of like that is a cool way of checking the relationship between our vectors. So when there is a 90-degree relationship, that is 0. When I'm moving this here, for example, that is going to be, right? So that is just kind of drawing, um, of course, it's not normalized. We normalize them here. Their distance is not 1 because 1 will be too small for us to see pretty much anything. So here, what is also crucial here that we can notice is the sign that we have. So if I move it here, even, as you can see, it's a positive sign. So basically, the first vector goes up, right? So that is our first vector. And the vector, and this, the other one, if that is located in this area, it's going to be a positive one. right? As you can see, if that is located in this area, if that is the positive one. If that goes down here, it's gonna be like with the negative one, with the negative sign, as you can see. So isn't that cool of how we can actually kind of, for example, imagine that that is the direction of your door, and you can actually get the doors that are having like the direction that shares this area, right? So if the other vector is within this area, this will be a positive vector. If not, it will be a negative one. So far, we understood that the dot product allows us to get the relationship between vectors. And what you're going to do on a daily basis is that figuring out whether two vectors are perpendicular or they share the same direction or they're opposite. And the dot product is the best for this. For example, if you have 90-degree again, it will be 0. If you have even 90-degree, but from this side, it will be 0. If you have opposite, right? So this one is looking there, this one is looking there. Again, keep in mind that they're normalized. It just like the lines. In Dynamo, we kind of make sure that we made sure that these vectors are normalized. So their length equals to 1. So if they're kind of looking at the opposite direction, so if there is an opposite relationship between them, it's going to give us like -1. And if they share the same direction, it's going to be 1. What if I wanted to do like a little bit differently? For example, imagine like a game when you are a player, for example, you're going like you have this first view and you're going somewhere. And usually the people that are for example, the people you want to have like your teammates, right? And you want the ones that are looking to the left have one visual representations and the ones that are looking to the right relative to you, you want them to have different visual representation. What does it mean? For example, you are this player who are looking right over here. And these are other players that are looking to the left. This one is looking there, or there, or there, or there. But we want to know actually now in this area. So for example, if a guy looks somewhere over here, for example, over here, I want them to be marked as the ones that are looking to the left relative to me. If they are looking to the right, like here, I want to mark them as relative to the right. And as you can see, I'm going to show you like how you can use this later on in terms of some visual representation. But just to understand how does that work? What kind of a problem do we have right now? Is that right now, actually, we can differentiate them by this area because in this area they're going to be with a plus sign, right? So I can actually ask whether A is bigger than 0, for example, right? I can ask whether A is bigger than 0, and then I can, and of course, if I were to have like a lot of them, I can easily differentiate. But now, I if I go there, it's going to be false, so that will be a problem. So what I can do, and now we will see the power of combining like cross product with this dot product. So if I go and think about what we're doing, what if I, out of this vector, could get the one that is looking right over here, right? And get, as we know, the relationship between this and this is that within this area it shares like one sign, within this area it shares the other sign. But what if we get like the one that is perpendicular to this one, right? Now, within this area, it will be with one side, actually like this, because as you can see, it goes there. This one looks here. And now it's going to be this side, right? So this vector, if I could get from this vector, this one, the perpendicular one, now I can differentiate these sides if we were to compare this with this. Okay, let's kind of create like a visual representation because it will be a lot easier for us. So we've got our main vector, like this one, right? The one that goes top. And I want to create a cross product. So, oops. So I go to geometry, abstract, vector, and I'm going to go and get cross. For the time being, let's say that our vector is never going to be like a 3D vector in terms of that won't go up, right? So it's always going to be like flat. Of course, if that would go up, we would need to come up with a little bit different decision solution actually, because here we're going how we can get this vector. For example, we have this one and get the perpendicular uh, to here. We can actually get the cross product between this and the z. So what I can do is that grab the base z vector that goes up. So as you can see the information about it, it has x0, y0 is at 1, so that is here, and the length is 1. 1 means it's normalized. So we've created this cross product. If you want to visualize it right now, so that is this one. If I kind of grab it and copy this, so you can see what does it mean. I'm gonna paste it here. It will give me this vector, right? Isn't that cool? Now we get the kind of the perpendicular one. Actually, a lot of visualizations. It's kind of really messy. Do this only when you kind of don't understand actually what is happening. Then you can easily figure that out without it. So now we can compare this vector that we had here, this one, with this vector, not with this one. And let's kind of see if we can just differentiate our vectors. So for example, if that is on the left side, I want this to share the same sign. And as you can see, it does. So if the vector is on the left, it's going to be with the minus sign. If it's on the right, it will be positive. As you can see, and now it is so powerful in terms of what we can do with this, right? So let's create something like, so now we know that if the vector is on the left, right? If the vector is on the left, it's going to be with the negative sign. If it's on the right, oops, okay. If it's on the right here, it will be with a positive sign. Imagine that you have, like, let me for the time being turn on to manual mode, and I'm gonna actually drop it to the other screen. Let's create a wall, for example, a circular wall, and place a bunch of like doors in it. I don't care that much about how many of them I have here. And actually, why am I doing this? Because what we can do is that let's for the time being, I'm gonna freeze it, right? I'm gonna freeze it. I don't want this part to work. I'm gonna go down a bit, and let's say that I wanna compare two of these doors based on this one. So let's say that we are the player that is looking here. So we are gonna be this door, and we wanna know the information relative to two of these. So what does that look like? So I'm gonna go select model element, just one element. I'm gonna select this door. And then, actually, I'm going to hide two of these doors so that it'll be easier for me to select them. Select model elements, model elements. And I'm going to go with select like that. Why have I done this? Because actually, right now we can actually do automatic. So out of our each family instance, we can get its facing orientation. So if we go to Revit, actually Dynamo doesn't have that much of power that Revit API has, but you can actually get some information, some cool information out of elements. For example, here we can find family instance, and as you can see under question mark, usually under question mark we have like what information you can get out of the existing element. So we have a family instance and we can get some information out of this. So we can pass uh, like family instance and get the vector. This vector will actually tell us where our wall, where our door is looking. So for example, if I want again to visualize it, I'm gonna go like this. I'm gonna copy this and I'm gonna paste it here so you can actually see this. I'm going to place this vector out here and out here. And as you can see, it's actually almost like intersects with the Y. Let's kind of move this a bit here, right? So this will go here. And that is correct, right? It's looking right over here. That is correct. So, but let's do the same with these ones. So I want to get the facing orientation. I want to get the facing orientation. And here I have like two vectors. And let's visualize them. So I can go vector and vector direction. And of course, here we've got like two. And here we've got like two lines, right? So that, yeah, because this one is actually visible. Yeah, I think you can go Control I, that will isolate elements because it still kind of remembers the visual representation of what we did here. So we would need to restart Dynamo, but I don't want to do this. So actually here we have this vector and this one, right? This vector goes here. This vector looks here. If I were to change this, for example, if I were to swap it here, it will look there. So now, as you can see, if we're talking like about like relative to this vector, so this vector is looking there, this one is actually on the left, and this one is on the right relative. How we can differentiate them is that it's kind of pretty simple with the power of knowing the dot product. So that is like the target one. So we can do the same what we did. We can go with the cross product of this vector to the z-axis, right? That is the vector that we want to kind of compare it to. So if I go copy this and paste and kind of just paste it there, paste it there. So this is what we get. So we've got this one. So that is like these direction of that door. So if I kind of check from this, right, it goes here, and that is the facing orientation of our door. But if we paste the cross product, it's going to be the perpendicular here. And now we can compare it with these vectors. Like now we're dealing with this. Yeah, actually, these are just for visual representation. So now we go with the dot product, right? Dot. And I go this one with these ones, like that. And what we can do right now is that now we can easily differentiate them. For example, let's go and ask. So we can use a node, whether it equals, I think, like this one, or whether it's more or equal, right? I really like to use just in a code block, right? Because that is a little bit much powerful. So a is bigger than 0. So if a is bigger than 0, like right now I'm gonna get like true and false, and I can go list filter by Boolean mask, and I can grab the list of these families that I have here. So let me kind of collapse this for a moment. So I'm gonna drop it down. The same goes for this one. And I'm gonna create, so what am I doing? I'm passing two of these elements that I have. And by using filter by Boolean mask, it will actually go there, see that I have two elements here, and I have two elements here, and that will check by index. For example, 0 is what? 0 is false. I'm gonna put this to out. And index 1 is true. So I'm gonna put this to in. That how that node works actually. So now if I go from in, that should give me the element under the index. under the ID, actually it ends with 80. So let's kind of visualize what I get. I just create a variable and pass it here, and that is 80. Let's see whether this 80 or not. Manage ID of selection. It's 70, so 80 is this one. Manage ID of selection, and that is 80. So basically, if it's more than 0, it's looking there. So that means that it's looking to the right side relative to our main door. Imagine that if you were, maybe you needed to kind of paint them in some way or do something with them. Just knowing the power of dot product can be so powerful. In the next lesson, I'm also going to show you one cool example of the power of dot product. And it's vitally important to kind of know at least this stuff because they can be so powerful. So to sum it up for like so far, we know that if we have two vectors and if you want to find out whether they're perpendicular or whether they share like the different orientation, because if I just go there again and kind of, for example, okay, we kind of understood this. I can easily delete it. Right, let's kind of go back to here. Okay, okay, I need to go and turn on Dynamo back. I'm gonna go with the manual so it's not gonna lag. So I'm gonna unfreeze it and I'm gonna run it. Just to sum up, because it's kind of vitally important for us. I don't want to go with the cross here. I'm gonna go with the vector itself. And I'm gonna go with the automatic. Why? Because I really want you to understand that how you can get the relationship. So for example, if vectors share the same side like this, it's gonna be 1. If vector are like in reversed, right? So this one is looking here and this one is looking here. This will be -1. If that is, oops, if that is like 90-degree, it will be 0. So as you can see how powerful it is. So using dot product, you can understand whether vectors share the same direction, whether they're opposed, right? So whether the other one is reversed relative to the first one, and whether they're perpendicular. And if that has some value, that means that it's kind of unknown, for example, in terms of the relationship. But knowing the value will help you more in terms of the sign it has, in terms of plus or minus. So you can get like the region of where your vectors are looking at. So if they are in this region, it will give you one side, one sign. If that is in this region, it will give you the other sign. If you wanna kind of have a slightly different one, we know the power of cross product, where you can get the perpendicular vector of this one, and actually you can get vectors that are looking in this area or at this area. So that is so powerful actually in terms of like analyzing, because usually when you get Revit elements, you can get their facing direction. You can somehow grab their direction actually, right? So that will help you a lot, and we will see other examples later on in this series. That's it for this lesson. I hope you enjoyed it. If you find the content useful, please like this video, subscribe to the channel, and turn on notifications. Thank you for watching, and have a nice day.